Indian space program started with the vision of harnessing the space technology for national development while pursuing the space science research and planetary exploration. It has societal and developmental application at the core, supported by the Indian Remote Sensing Program, the Indian National Satellite Communication and Navigation Program, to support that our own launch vehicles and also the space science and exploratory programs. It all started with a demonstration of a coconut root wilt disease study carried on an aircraft in the Kerala, where coconut root wilt diseases were picked up using the infrared images picked up from the aircrafts. Starting with that, we had first set of satellites, Bhaskara series, Bhaskara 1 and 2, which were launched using the collaboration with Russians who offered to launch a couple of satellites for us. And this is how we started our remote sensing program. And the Bhaskara satellite, of course, had both the optical and microwave instruments. And starting with this, where the complete process of building an optical and microwave instruments and then collecting data and then providing it to the users, we started our Earth observation capabilities. And the geostationary platform activities started with our INSAT-1 series, where 2-band images at 8 kilometer resolution is what we started with, which was producing in the early 80s about 4 images per day, gradually built up from 2 bands to 3 bands, and then today we have INSAT 3D, which provides in 6 channels images at 1 kilometer resolution, and also a humidity and temperature profiling sounder, 19 channel sounder, which provides about 48 images in a day. After the Bhaskara series, we started our Indian remote sensing satellite program with 36 meter and 72 meter resolution, covering once in 22 days, gradually built up the capability to what we have today, 1 kilometer daily coverage to 0.8 meters, once in 5 days, a capability in various multispectral and panchromatic bands. We also have a OceanSat series, which provided 360 meter resolution ocean color information, which was the backbone for the prospective fishing zone information being provided to our fishermen. And then we had the radar imaging satellite and also the scatterometer and the megatropics and Saran. These are the series of Earth observation satellites which we built over a period of time. Some of the key developments happened is we were among the early adopters of the push broom technology, which enabled us to use for provide both in ocean color as well as from geostationary platform very high resolution imaging system. And we were among the first to provide what we call as a 3-tier imaging system, which was specially designed for making observations of the agricultural parameters for our country, taking into account the very small field sizes we had and a combination of very large swath, high repeativity data to high resolution and medium repeativity capabilities. And we also built in the capability of providing very high resolution images of 1 meter using technology experiment satellites. We continued this, and one of the key things required for our country was the digital elevation model, and we built one of the highest spatial resolution optical imaging system. And today, using this Cartosat 1 series, we have the digital elevation model for the entire country, which is being used for a large number of our developmental activities. Then in our country, we have almost 4 to 5 months of excessive cloud cover to ensure that you get Earth observation information. It's essential that we develop the microwave imaging system. And we started with the Samir, the first microwave instrument in the 79 and 81 time frame. With that, we gradually built the multi-wavelength scanning microwave radiometer, and then a scatterometer, which was flown in 2009, and a C-band synthetic aperture radar. All of this indigenously developed and then providing operational inputs for various users. Similarly, with one of the key developments we had is the infrared sounder, which was launched in 2013, and this is from a geostationary platform, which forms the backbone for providing almost 40 vertical temperature profiles, and then integrated ozone content, and also the improved resolution cloud cover images for various weather forecasting activities. Today we have 13 thematic Earth observation satellites in orbit, which along with the digital elevation model data generated from our Cartosat, and also the positioning information which we can provide using the navigation satellites and the Gagan, that is geo-augmented GPS service data sets. This forms the backbone for a large number of applications which makes use of all this data and provides to the country a host of inputs necessary for developmental work. We have again the development of data reception, processing and archival, starting from the 80s, where we first started receiving the Landsat data. Today we have a host of our own satellite plus the satellites from international operations being used and disseminated to a large number of users within the country. And we also have a number of ground observing networks supporting the information required from Earth observation platforms to essentially provide various inputs required for weather modeling and other modeling activities. While we built the space system, we also worked with the various ground departments of the Government of India and the states of our country, where we set up what is called a National Natural Resource Management System, which made use of the infrastructure available at a large number of government departments by bringing them and bringing the information to these communities. We were able to establish a large number of application activities, and today we are working with almost 58 ministries and departments for providing the necessary input from both Earth observation as well as in situ observation capabilities, which we have established over the last 4 decades. Many of these things have become operational usages under the department. For example, Ministry of Environmental and Forest, the Forest Department of Forest Survey of India provides every 2 years the complete forest cover maps, and Ministry of Earth Sciences provides the prospective fishing zone advisory to the fishermen and also the weather information, and Ministry of Agriculture and Water Resources and also Geo and Morphological Lineament Studies, Geological Survey of India, all of them have established their own departments for making use of Earth observation information in their day-to-day activities. And another major activity that has been done using the space technology is the disaster management support system. Like Al pointed out that today we have an effective mechanism of informing the community about the landfall of cyclone within an error of half an hour and 20 kilometers in position, which has become the backbone for the disaster relief agencies to carry out the necessary evacuation and save a large number of lives. And apart from this, the flood early warning system for the Northeast, and also the forest fire monitoring, landslide and emergency communication system, and also we are establishing what's called a National Disaster Management Control Center with necessary information for dealing with the disaster situations. And we also support international initiatives for international charters, Sentinel Asia, UN ESCAP, UN SPIDER, and sharing of best practices and experiences in disaster management. And in the recent past, we have provided a significant amount of data for these activities. In 2014, for example, we had activated about 32 times and provided a large number of scenes. In 2015, almost 155 scenes were provided. And we also work in close collaboration with Sentinel Asia. And today we have within the country a couple of very important information dissemination systems, details of which later you will hear from Dr. Dadwal, what is called Bhuvan and also the MOSDAC, then the India Varis, where each of these portals provide real-time, near real-time information for a large number of governmental activities. It provides capability of visualization of satellite data and also geolocated image base, and both for meteorological information and a large number of information about 100 geospatial layers and more. We work with international agencies for many activities. We have collaborative arrangements with about 37 countries and 4 multinational bodies and more than about 200 memorandum of understanding, and still some more negotiations with 6 countries for establishing cooperation is in progress. And the kind of collaborative work we do is joint satellite missions, accommodation of payloads of other countries in our missions and our payloads in other countries' missions, data exchange, sharing of resources, ground station, capacity building, and also joint experiments on calibration and validation. And as pointed out, the megatropics was one good example of what has been already achieved. Then similarly, Saral Altica, which carries a Ka-band altimeter, and Argos data collection platforms. And this data has become very useful for us in many of our endeavors to provide useful information. And this is another major activity which is currently in progress, the NASA ISRO Synthetic Aperture Radar mission, wherein a joint payload development between NASA and ISRO on L and S band SAR. The payload is being accommodated on a satellite of ours, and we intend to launch it in the year 2020. And it's going to provide a very significant capability in natural resource mapping and monitoring, agricultural biomass over the full duration of crop cycle, soil moisture, monitoring of floods, and a host of other activities. On the anvil, we are currently in dialogue with KENES on satellite with thermal infrared sensor, JAXA for a new mission on climate change studies. With NASA, we are further discussing on climate observing missions, atmospheric and oceanographic missions. Then we have EO experiments and CalVal activities, and we are also thankful to JPL NASA for providing an airborne hyperspectral imager which we have flown over our country, and the data analysis is in progress. K-band propagation studies with France, and then rapid SCAT and SCAT-SAT calibration activities with NASA and NOAA, and with CSA, Canada and Italy for RISAT-1. And we have got data exchange and sharing activities with a large number of agencies, starting from USGS, UMETSAT, ESA, and we are also looking at a virtual remote sensing satellite constellation for BRICS and Asian and storm activities, where weather observation and network with AWS, DWR, Doppler weather radar, and GPS radio sound is being provided for our neighboring countries. Currently, we'll continue to provide the basic observation capabilities in land and water, where we have our ResourceSat 2 series will be augmented by ResourceSat 2A this year, followed with ResourceSat 3 series, which will be a significant improvement, and we will have continuity of our radar imaging satellite, cartographic observation, OceanSat series, and also the INSAT 3D series, which will be continued. One of the major developments is we are constantly improving on our observation capability by enhancing the kind of input that is being provided. While you maintain continuity, you also ensure that there is enhancement in the capability of the system. We are coming up with ResourceSat 3 series, which will provide almost 900 kilometer swath at about 20 meter resolution, and it will also carry along with a sampler at 1 meter stereo capability with about 2.5 meter multispectral with a large swath of 60 kilometers. Another interesting instrument we are going to fly is GISAT, a geoimaging satellite from geostationary platform, which will carry multispectral as well as hyperspectral instruments in visible and shortwave infrared. This is going to provide a very significant opportunity for conducting many R&D studies, which will later become operational systems. And then in terms of space exploration, we started our work with Chandrayaan-1, which did have the privilege of discovering the water processes, water molecules discovered on Moon Mars orbiter mission, which provided an extremely interesting opportunity of doing planetary missions at fairly low cost. Then recently we also had an AstroSat, which is a multi-wavelength observatory launched last year. In the immediate future, we are looking at Chandrayaan-2, which will carry our own orbiter, lander and rover, and then another interesting mission called the Aditya L1, which is a solar mission for studying the solar coronagraph, and it will also have magnetometer systems for studying the magnetic field. We are also looking at an opportunity to do a paired mission of L1 and L5 for Aditya follow-on. With this, what we are looking at is having a well-developed Indian remote sensing program, which is open for international cooperation, for advancing the technology, for ensuring that we can get information of protecting the planet Earth, exploring the universe, which in turn should be benefiting the humanity. Thank you.